Today, we're going to talk about dimensional analysis. In physics, dimensional analysis speaks of the dimensions of a physical quantity, and we are referring to the type of the quantity. For instance, given the formula, initial distance is equals to initial velocity times time plus 1/2 acceleration times time squared. So now, let's make this dimensionally correct. We know that the formula of velocity is given meter per second. And we can describe it dimensionally as length over time. For meter is the base unit of length and seconds is the base unit of time. And now let's continue. For acceleration, we know that acceleration is equals to meter per second squared. And in dimensionality form, it will become length over time squared. So let's now derive the given formula. Initial distance is equals to length and initial velocity is equals to length over time and remain the quantity of time. Plus, let's neglect 1/2 for its dimensionless. So acceleration is equals to length over time squared and remain the quantity of time squared. So let's do the cancellation now. So length will be equal to length plus length. And length is equals to length plus length is equals to length. So it will be dimensionally correct. And as we solve it, we can say that it is dimensionally correct. Let's have another example. Given the formula, final velocity is equals to initial velocity plus acceleration times time. And let's prove that this equation is dimensionally correct. We know that velocity is equals to meter per second. And it is equivalent to length over time in base unit. And for acceleration is equals to meter per second squared. And it is equivalent to length over time squared. And let's now derive the given derivation to the given formula. Final velocity is equals to length over time and initial velocity is equals to length over time also. Plus, for acceleration, it's length over time squared and remain the quantity time. So now, length over time is equals to length over time plus length over time. As we could see, all the denominators are time. So let's do the cancellation now. So the equation now will be length is equals to length plus length. So length now is equals to length. So as we solve it, we can say it is dimensionally correct. For the third and last example, given the formula, time is equals to 2 pi times the square root of length over gravity. First, let's describe each value. We know that 2 pi is neglected because it's dimensionless, and length will remain length. And for the gravity, we know that gravity is the acceleration due to gravity and it is equals to 9.8 meter per second squared. And 9.8 will be neglected because it's dimensionless. So let's derive the formula now. Time will be equals to square root of length over meter per second squared. And now, meter per second squared can be equivalent to length over time squared. And now, let's divide length over time squared. So T will be equals to square root of length times T squared over length. Let's cancel length now. Remaining time is equals to the square root of T squared. And the square root of T squared is equals to T equals to T. And as we solve it now, we can say that it's dimensionally correct.